Morning, my dear students. I am Momin. Welcome to my physics class, Standard 9, Subject Physics. Our today's chapter is Physical Quantities and their measurement. This is your first chapter of physics, and this is the first class of physics. At first, look at the pictures below. What are you seeing here? This is 42 and 5 kg. Here 5 kg is the what of 42. Here 5 kg is the mass of 42. And here 10 meter cable. Here 10 meter is the what of cable. Here 10 meter is the length of cable. So here mass and length are physical quantity, and kg and meter are their unit. That is, here mass is a physical quantity and kg its unit. That is, here 5 kg 42. That means mass of the 42 is 5 kg. So mass is a physical quantity and kg its unit. And here length of this cable is 10 meters. So here length is a physical quantity and meter is its unit. So mass and length are physical quantities, and kg and meter are their unit respectively. Here kg is the unit of mass and meter is the unit of length. So our today's topic is physical quantities and their measurement. Let's start now. Physical quantity. What is physical quantity? Actually, something that can be measured is called physical quantity. Example, we can measure the mass of something, so mass is a physical quantity. We can measure time, so time is a physical quantity. We can measure length of a body, so length is also a physical quantity. That is, something that can be measured is called physical quantity. Here example, mass, time, temperature, etc. There are two types of physical quantity. One, fundamental physical quantity, and two, derived physical quantity. Fundamental physical quantity. The physical quantity which does not depend on other quantity, that is independent, is called fundamental physical quantity. That is, this type of quantity are independent, that is they do not depend on any other type of quantity. And there are 7 fundamental quantities. So by these 7 fundamental quantities we can measure everything of the world. So only if we measure the 7 fundamental quantities we can measure everything. And fundamental quantities do not depend on any other quantity. Other quantities depend on fundamental quantities. Example, mass is a fundamental quantity, time is a fundamental quantity. And derived physical quantity means the physical quantities which are derived from fundamental quantities are called derived physical quantity. That is, the physical quantity which are derived from fundamental quantities are called derived physical quantities. This type of physical quantity depends on fundamental physical quantity. Example, velocity. Velocity depends on distance and time. Here distance is one kind of length and it is a fundamental quantity, and time is also a fundamental quantity. So velocity depends on length and time. So length fundamental quantity, time fundamental quantity. From these two fundamental quantities we get velocity. So velocity is a derived quantity. Also weight is a derived quantity, and force is also derived quantity. We know there are 7 fundamental quantities, and these 7 fundamental quantities are length. Length is a fundamental quantity, mass, time, temperature, electric current, luminous intensity, amount of substance. These 7 quantities are fundamental quantities. If we measure these 7 fundamental quantities, we can measure everything of the world. Seven fundamental quantities and their SI unit. Here SI unit means international unit. Here 7 fundamental quantities and here their units. Length is a fundamental quantity and its unit is meter, and meter is denoted by m, that is symbol of meter is m, small m. And mass, unit of mass is kilogram, that is international unit of mass is kilogram, and it is denoted by kg. Time is a fundamental quantity, its unit is second and it is denoted by s. Electric current, it is also a fundamental quantity and its unit is ampere and its symbol is capital A. Temperature, its unit is Kelvin, international unit, that is SI unit is Kelvin, and it is denoted by K, that is symbol of Kelvin is capital K. Amount of substance is a fundamental quantity, its unit is mole, and unit of symbol of mole is MOL. And luminous intensity is also a fundamental quantity and its unit is candela, and candela, symbol of candela is CD. So these are 7 fundamental quantities and these 7 fundamental units, and these are the symbols of these fundamental units. So there are 7 fundamental units of 7 fundamental quantities. These 7 fundamental units do not depend on any other types of units. Seven fundamental quantities and their SI units. The 7 defining constants of the SIR. If we want to define the 7 fundamental units, we need 7 constants. According to the new definition of 7 fundamental units, we need 7 fundamental constants, and these constants are the cesium hyperfine frequency, that is the number of vibration of cesium 133 atom, the speed of light in vacuum C, it is also a constant, the Planck's constant H, the elementary charge E, the Boltzmann constant K, the Avogadro's constant Na, and the luminous efficacy of a defined visible radiation KCT. These 7 constants are needed to define 7 fundamental units. Magnitude of 7 fundamental constants essential to measure 7 fundamental units. Here constant velocity of light, its magnitude is 299792458 meter per second. Planck's constant is 6.62607015 into 10 to the power minus 34 joule second. And charge of electron 1.6 into 10 to the power minus 19 coulomb. This is the charge of electron. The cesium hyperfine frequency, that is the number of vibration of cesium 133 atom. Here 91926317770 Hertz. Boltzmann constant Kb 1.380649 into 10 to the minus 23 Joule per Kelvin. Avogadro's constant Na 6.022140076 into 10 to the power minus 23 particles per mole. And luminous efficacy KCT 683 lumens per watt. So this is the magnitude of 7 fundamental constants, and we need these 7 fundamental constants to define the 7 fundamental units. We know there are 7 fundamental physical quantities and there are 7 fundamental units, and to define these 7 fundamental units we need these 7 fundamental constants. Now the new definition of 7 fundamental units. Second, and the symbol of second is S, and it is the unit of time. We know it. The international unit of time is second. The time required to complete 91926317770, that is the time required to complete this number of vibrations by cesium 133 atom is 1 second. That is, time required to complete this number of vibration by cesium 133 atom is 1 second. In 1 second, cesium 133 atom completes 91926317770 vibrations. And meter is the unit of length and its symbol is m. In vacuum, the distance traveled by light in this second is called 1 meter. In vacuum, the distance traveled by light in 1 divided by 299,792,458 second is called 1 meter, and this number is the velocity of light. Kilogram. Kilogram is the unit of mass. International unit of mass is kilogram, and its symbol is kg. The mass which is obtained by dividing Planck's constant by 6.6260715 into 10 to the minus 34 meter square per second is called 1 kilogram. And this number is the Planck's constant. If we divide Planck's constant by this number, the amount of mass is 1 kilogram. Now ampere is the unit of electric current, and it's a fundamental unit. Its symbol is A. Flow of 1 divided by 1.6021766634 into 10 to the minus 19 numbers of charge equivalent to charge of electron in 1 second is called 1 ampere. That is, flow of this number of charge equivalent to charge of electron in 1 second is called 1 ampere electric current. This is the definition of ampere. And mole is the unit of amount of substance, and its symbol is MOL. Amount of substance that contains 6.022140076 into 10 to the power 23 particles, that is, this is the Avogadro's number, is called 1 mole. That is, amount of substance that contains this number of particles is called 1 mole substance. Kelvin is the international unit of temperature, and its symbol is capital K. Amount of change of temperature with the change of 1.380649 into 10 to the minus 23 joule thermal energy is called 1 Kelvin. That is, amount of change of temperature with the change of this joule thermal energy is called 1 Kelvin. Candela. Candela is the international unit of luminous intensity and its symbol is CD. The candela CD is the luminous intensity in a given direction of a source that emits monochromatic radiation of frequency 540 into 10 to the power 12 Hz and that has a radiant intensity in that direction of 1 divided by 683 watt per steradian solid angle. This is the definition of candela, that is the unit of luminous intensity. Here monochromatic radiation means the radiation of a single wavelength. So monochromatic radiation means radiation of single wavelength and frequency means number of vibrations. And so if we want to define 7 fundamental units, we need these 7 fundamental constant C, del V, E, K, N, A, K, D, K, C, D and S. We need these 7 fundamental constants to define the 7 fundamental units. So physical quantity means something that can be measured is called physical quantities, and there are 2 types of physical quantities: fundamental physical quantities and derived physical quantities. The physical quantity which does not depend on any other type of physical quantity is known as fundamental physical quantity, and derived physical quantity means the physical quantities which are derived from the fundamental physical quantity. And we know there are 7 fundamental physical quantities, and from these 7 fundamental quantities all the physical quantities are derived from these 7 fundamental physical quantities. And there are 7 fundamental units, and the definition of 7 fundamental units are given by these 7 fundamental constants. Now evaluation: what is the unit of luminous intensity? A. Kelvin, B. Ampere, C. Second, D. Candela. What is the unit of luminous intensity? Think it. And the answer is candela. That is, the unit of luminous intensity is candela. Number 2, which one is not a fundamental quantity? A. Weight, B. Time, C. Temperature and D. Electric current. Which one is not a fundamental quantity? Weight, time, temperature, electric current. Which one? Weight is not a fundamental quantity because we know time, temperature, electric current. Time is fundamental physical quantity, electric current is fundamental physical quantity, and temperature is also fundamental quantity. And weight is not a fundamental quantity because weight is derived physical quantity. We know weight depends on mass and acceleration due to gravity, so weight is not a fundamental quantity. Now your homework: what is the difference between fundamental quantity and derived quantity? My dear students, try to solve this question and submit it as soon as possible. Thank you very much.